Okay. Shall we start? Can you just confirm once? Because for me, from my side, I'm able to just hear the voice. Is my audio audible?
Yes, sir.
Okay. Thank you. Thank you. So I'll record the session as well. So in case anyone misses out, I don't think anyone has. There's one more student. Okay. No problem. So we'll get started. And today I'll be starting with linear inequalities, which is, I think, in your textbook. I think it is chapter four, fifth, five, right? It's not six, but anyway, we'll be starting with linear inequalities. So first, we will understand both the words, right? So what is linear? When do we call anything linear? Linear is a straight line, right? English word, and we have something called linear motion as well, right? So straight line motion is known as a linear motion. So if I have a straight line, that represents anything linear. Now coming to math, in math, what is linear? If I have any equation or inequality which has the highest power of the variable to be 1, in that case it is known as linear. For example, x plus 3 is equal to 4. This is a linear equation, right? If I write x square plus 3 is equal to, say, 2x, this becomes a quadratic equation. And if I write x plus y is equal to 3 and 2x minus plus, say, 3y is equal to 6, this becomes linear equations in two variables, right? Similar to that, this is the meaning of linear. The highest power of the variable that you will be seeing over here is going to be 1. Now coming to inequalities, I think just the word, by looking at the word, you can know, right? If something are not equal, they are known as inequalities. Now how many types of inequalities are there? There are four types of inequalities, and I'll be telling you about open close intervals as well. Those are very, very important. So there are three particular symbols that we use. The first one is greater than, this particular symbol is going to be less than, and this is, of course, you know already, it is going to be equal to. Now there is an easy way to remember, because there is a possibility that sometimes you may be getting confused between these two, right? Because both of them look the same, just the direction is going to be different. So what you have to do is you assume that this particular symbol looks like the crocodile's mouth. Okay, so wherever the crocodile is opening its mouth, here will be having the highest number or the greatest number, right? Along the tail, the number is going to be small. This will work for both of them. Let us check. For example, this is greater than. If I write this, right, this is true. I see that the crocodile is opening its mouth towards the bigger number, right? Either I can write it this way, or the same statement can be written down this way as well. Okay, so if crocodile is opening its mouth towards your left hand side, in this case it is called a greater than symbol. If it is opening towards your right hand side, it is going to be less than symbol. So this you can remember, right? And of course, equal to, I need not tell you at all. Now before I come to linear inequalities, types of linear inequalities, or let me tell you about it, and then I'll be going to the types of brackets or types of intervals that you'll be having, right? So there are about five types of inequalities. The first one is numerical inequality. The second one is going to be literal inequality. Third one, we have double inequality. Fourth one is strict. Fifth one is slack. I'll be giving you an example so that you'll be understanding. The best example for numerical inequalities is something like this: 6 is greater than 3. Yeah. Literal inequality would be if I have any variable, right? For example, a plus b is greater than c, something like this. Double inequalities, when we have inequalities on both the side, I can write it this way. So 6 is going to be less than 10, and 10 is less than 15, right? Something like this. I have two inequalities over here. This is called double inequality. Strict inequality would be when I have only greater than or less than. Slack inequality would be whenever I have greater than or equal to, less than or equal. So these are the types of inequalities that will be studying. Anyway, you need not know about the types, I have just given for your information. Okay, now coming to the working rule, and I'll tell you about the working rule. Before that, I want to discuss about the interval notations. These are very very important, and as with these, the number lines as well, right? So there are about three types of intervals. I hope you know what an interval is, right? So when do you buy popcorn? If you go to PVR during interval, isn't it? During the interval is what you'll go buy popcorn, right? So what is interval? Interval is the time in between the movie, right? In between something, we call it an interval. How many types of intervals are there? There are about three types of interval. The first one is called open, the second one is closed, the third one can be called semi open or semi closed. Both are one and the same, right? Semi-open or semi-closed. Now, coming to open interval, how do we represent open interval? Open interval is represented using normal parenthesis or normal brackets. I can write this way, right? I can have a number over here, I can have a number over here, and I can take the interval. Similarly, the closed interval is represented using square brackets. Similarly, semi-open or semi-close is going to be representing both open and close. And for all of this, I'll be giving you a simple example. Let us start with an open interval, right? If I have an open interval a comma b, what does this mean actually? This means that I can take any value of x which is in between a and b. Let me give you an example over here, numerical example, right? If I write down 5 and 10, here I can consider the elements 6, 7, 8, 9. This is what it means if I write 5 comma 10 in open interval. Similarly, if I write down the same thing in closed interval, it is going to be square brackets, and here the value of x is going to be greater than or equal to a and less than or equal to b. Similarly, I will write down both of the things, right? So here you have to include this one, so it is going to be 5, 6, 7, 8, 9, and 10, right? So these are the elements that I can take up if I'm talking about the closed interval. Coming to semi-closed, we have three types, or rather two types, right? Semi-closed or semi-open, both are one and the same. Here I can have starting an open interval with a, ending up with the closed interval. Either I can have it this way, or it can start with the closed interval and it can be ending up at the closed interval, right? So over here, what does this mean? This would mean that I can take up a value of x which is greater than a, but it should be less than or equal to b. In this case, it would mean that I can take up a value of x which is going to be equal to or greater than x, but it should always be less than b. Again, I'll be taking up the same numbers over here. So 5 comma 10, if I write down, what would this mean? This means that I can take up any number starting from 6, 7, 8, 9, and 10 as well. But over here, the second term, I can write down 5 starting with the closed interval and ending up with the open interval. Here I can start with 5, 6, 7, 8, and 9. 10 cannot be taken in this case, right? So these are about the types of intervals. We have four types of intervals: open interval, closed interval, and semi-closed. Open is represented using the normal brackets, close is represented using the square brackets, and this is how we represent the interval in terms of inequality, right? This is how we represent in terms of inequality. Now, coming to working method of inequalities, there are two things again which you have to remember, right? The first one is very very easy. You should be solving your inequalities just like you solve your equation. For example, if I have x plus 3 is equal to 13, how do we solve this? We bring 3 to the other side, so x can be written down as 13 minus 3. The value of x is going to be 10. This is how we solve, right? Similarly, we solve inequalities as well. For example, x plus 3, if it is greater than 13, In this case, I will use the same logic. That is, I will transfer 3 to the other side. X is now going to be greater than 13 minus 3. X is going to be greater than 10. So this is one of the solution for this particular linear equation. This is an inequality. Inequality will have infinitely many solution, right? You can take up any value of x greater than 10. This particular inequality will work. So the first working rule of inequalities is very easy. You should be solving the inequalities just like you solve your equation, right? This is a no-brainer. The second point is very, very important because there is a small change over here. For example, if I have negative 2x, right, plus 6 giving me, let us assume it is 16, right? Now, how do we solve this? When I transfer 6 to the other side, I'll be getting negative 2x plus 6, which is going to be equal to 10. I'll directly write down, okay? Yeah, 16 over here, I will transfer this. So negative 2x can be written down as 16 minus 6. Negative 2x is going to be equal to 10. Divide both sides by negative 2 and the value of x is negative 5. Right? This is how we solve our linear equation. But what if we have inequalities? Then it is going to be changing a little bit. And the point that you have to remember is whenever you multiply or divide a negative number, I will repeat it again. When you multiply or divide a negative number and you are working on inequalities, your inequality will flip. What do I mean by that? If I have greater than, it will turn to less than. If I have less than, it will turn to greater than. Similarly, greater than or equal to will be turned to less than or equal to. Less than or equal to will be turned to greater than or equal to. Let me take up the same example and I will show you how that works. Okay. Let me start by taking negative 2x plus 6 is say greater than 16, right? Now, in order to solve this, again, the first step remains the same. I should be transferring 6 to the other side. So negative 2x is now greater than 10. Dividing both sides by negative 2, what happens? So these two can be cancelled out. And as of now, I will not flip the inequality and I will show that this is not true. Okay. So here, if x is greater than negative 5, do you think this is the right option? No, I don't think so, right? For example, I can take x, value of x, which is going to be greater than negative 5, right? So can I take say 1? 1 is greater than negative 5, right? Yeah, substitute the same thing over here. So negative 2 multiplied by 1 plus 6, is it greater than 16? No, no. The answer is going to be 4. So this is not the solution set, right? So whenever I'm dividing or multiplying any negative number, the inequality will flip. Here I had greater than sign. This will become less than sign. Now we will check whether it works. Let me take the value of x as say negative 10. Negative 10 is less than negative 5, isn't it? Now let me substitute back over here. So negative 2 multiplied by negative 10 plus 6. Here I'll be getting 26. 26, is it greater than 16? Yes, it is, right? So these are the two rules that you have to remember. And the second point is very, very important. That is, whenever you multiply or divide a negative number while solving the inequalities, the inequality will always flip. The inequalities will always. Is it clear? Easy, right? So what we have discussed is what is inequality, what are the types of inequalities, and I told you a method to remember all of them, right? And I told you about intervals. There are about three types of intervals: open, close, and semi-open or semi-closed, right? Then I told you two things about working rule of inequalities. The first one is going to be very, very easy. You just have to solve your inequalities just like you solve your equations. The second one is going to be whenever you multiply or divide with a negative number, the inequality is going to be flipped over. As simple as that. Okay. Now, with this particular information, we can start solving the question. So quickly, I will start questions from the exercise and I'll be taking up the other questions as we go forward. The first question says, solve 24x less than 100 when x is a natural number and when x is an integer, right? So what are the values of x for this particular solution set, right? So let me start by making a note of the first one. So 24x is less than 100. What are natural numbers? Natural numbers are all the numbers starting with 1, 2, 3, 4, 5, 6, and so on, right? Which means that the first value of x that I can take up is how much? It is 1. right? Rather, I can just find out the value of x over here, divide both sides by 24. So x is going to be greater than, or sorry, less than 4, and here it is going to be 24, right? So 4 point something. Can I write it this way? And not, I don't want the exact answer. So I know that the value of x is going to be less than 4 point something. So what are the natural numbers which are less than 4? We have 1, we have 2, we have 3, and we have 4 as well, which means this is the solution set for the first inequality where x is going to be a natural number. Okay, similarly, let me take up the second one as well. The second one is, again, the equation remains the same, but here x can take up any integer now. Any integer now, right? Again, when I solve by just dividing both sides by 24, I see that the value of x is going to be less than 4 point something. So what are the integers that are less than 4 point something? So it is going to be negative infinity and so on, then negative 5, negative 2, 1, 0, and then 1, 2, 3, and 4. This is the solution set, isn't it? Yeah. Now, how can I express this? I should be expressing it this way, right? I will start with an open bracket and I will write down negative infinity, because negative infinity cannot be considered. Any number less than negative infinity I can consider, right? Because infinity is not a fixed number, right? It can vary. Depending on your imagination, it can vary. So I can start by writing down the solution set as open bracket negative infinity comma comma. Here we have 4. Yeah. Yes, so 4 can be taken, and here I can close it with a closed interval. Now what does this?
Sir,
Yeah.
but this way it will also include the decimal values, right?
No, here I'm considering as integers, right? Check over here, this one.
Yeah, but then when we write it as intervals, won't it also include the decimal values?
No. Sorry, if I don't mention this, in that case, here you can mention x is going to be an integer.
Okay.
You can do that. Any integer in between these two will work, right? Of course, if I just write this down, right, without any context, in that case, yes, we can have 3.5 as well, for 2.5 as well, right? Even this is going to be coming in the interval. Yes, true. But here you can mention one thing, that any number inside, right? Or you can write it this way, right, where x is an integer. Okay, got it?
Yes, sir.
All right, or you can just mention the solution set as well, right? This way, whatever I have done, this is also fine, this is also fine, or you can plug it in this way. Anything, both are going to be equal. Let me go to the next one. Here again, it is the same kind of question, but there is a small difference. What is the difference? It is negative 12x, right? So negative 12x is greater than 30. When I divide both sides by negative 12, what will happen to the inequality? The inequality will flip over, right? And 25 30, it is going to be about 2.5, right? Negative 2.5. So these are the solution set, isn't it? Again, x is going to be a natural number. Which are the natural numbers which are going to be less than negative 2.5? No natural number. Yeah. So there's going to be no solution at all for this one, meaning that you cannot have a value of x such that this inequality will come true ever if x is going to be a natural number. Because you take up any natural number, of course, if starting with 1, 1 multiplied by negative 12 is going to be negative 12. Negative 12, is it greater than 30? No. Negative 2, 2 multiplied by negative 12, again no. Any number multiplied by a negative number would be a negative number itself. If I'm starting with a natural number, so the first one will not have any solution at all. Okay, now coming to the second one, it says that here x is going to be an integer. If x is an integer, I can take up all the integers which are greater than, oh sorry, less than negative 2.5, which means it is going to be negative 3, negative 4, negative 5, and so on until infinity. So this is going to be the solution set. Okay, for the second one, this is going to be for the second one. First one will not have any. It will not have any. Now coming to the third one, right? Here we have similar question, but 5x minus 3 is going to be less than 7. Again, we'll start by solving this. 5x minus 7 is less than 7. So you can transfer 3 to the other side. 5x is going to be less than, I can directly write this as 10, and dividing both sides by 5, I'll be getting the value of x, which is going to be less than, right? Now let me solve the first one. The first one says that x is going to be an integer. Yeah. So what are the values such that the inequality will hold good? So I can take up any number starting from infinity, and I can keep on coming negative 3, negative 2, negative 1, 0, and 1. So this is the solution set for the first one. Coming to the second one, it says that x is a real number. Since it's a real number, you can just plug in negative infinity, comma 2 under open brackets. Under open brackets, 2 cannot be considered, right? So any real number here, and here you can start by writing x is a real number. And how is x? It is less than, so x is going to be greater than negative infinity, and x is going to be less than 2, right? This is what it means. I hope it's clear. Easy, right? Let me go to the next type of question, and here this, I think, linear equation, if you have it, is going to be very easy. Now let me take up rational inequality as well, this type, right? So if I have rational inequalities, in that case, how do I solve this? Again, it's going to be very easy. You start by taking up the LCM, or you can try bringing in the values of x to the one side, and then you can cross multiply as well. So the same inequality can be written down as x over 3, which is going to be greater than x over 2 plus 1. You transfer this to the other side. So x over 3 minus x over 2 is going to be greater than 1. Now you can take up the LCM over here. So I should be getting 2x minus 3x divided by 6 is going to be greater than 1. You can cross multiply. 1 can be written down as 1 over 1. And now you can use the cross multiplication method. When I cross multiply, here negative x is what I'll be getting, which is going to be greater than 6. But here I see that I have which type of, the negative sign is there, right? I cannot have negative sign. In that case, what can be done? Should I be dividing, multiplying, anything? Or this itself is going to be the answer? I can divide, right? So I can divide both sides by negative 1. Negative 1, it can be done. So negative signs are going to be getting cancelled out. And now the value of x, I can write this as it's going to be less than 6. So this is going to be the final inequality that I'll be having. Now, how do I represent this? I need to represent this as negative infinity, comma, 6 in open brackets. So this is going to be the
Sir, isn't it minus 6?
minus 6. Yes, it is going to be minus 6. We are dividing with negative 1, right? So it is going to be negative 6. Yes. So negative infinity until negative 6. This is going to be the solution. Okay, let me take up one more, and we have word problems based on it as well, right? So this is another question. 3 multiplied by x minus 2 over 5 is going to be less than 5 multiplied by 2 minus x divided by 3. Start by multiplying the same thing. So it is going to be 3x minus 6 over 5, which is going to be less than or equal to 10 minus 5x divided by 3. Again, you can do one more thing, right? You can multiply both sides by 3 and 5, or 15 rather. Both are one and the same. Okay, now watch what happens. So 5 and 5 will be getting cancelled over here. 3 and 3 will be getting cancelled over here. And further I can expand. Now here it is going to be 9x. 9x minus 18 is going to be less than or equal to 10 multiplied by 5 is going to be 50 minus 25x. Yeah, now you can bring this to the other side or 25 to the other side. Either way, you should be getting your answer. I will bring this over here. I will transfer this over here. So it is going to be 9x plus 25x, which is going to be less than or equal to 50 plus 18. Yes, what is going to be 50 plus 18? 50 plus 18 is going to be 68, and here it is going to be 34x. I will start by dividing both sides by 34. Right, when I divide both sides by 34, I'll be getting the value of x, which is going to be less than or equal to, this is going to be the solution. What is going to be the solution set? The solution set is going to be equal to, starting with an open bracket, negative infinity, and it will end at 2, so it is going to be a closed bracket. Right, so this is going to be the solution. This is the solution set. I hope it's clear. And what is the difference between the solution and the solution set? You have to write down both of them. Okay. Most of the times you have to write your solution set. Why solution set? Because we'll be having infinitely many solution for inequality, unlike equation. Right? Equation can have only one value for x, such that the left hand side and the right hand side match. Here, if I can have infinite many values of x, such that the inequality will match. So this is going to be the solution set for this particular equation. I hope it's clear. Let me take up one more question over here, such that you'll be getting a better idea. Okay, I think, what is this? Let me erase okay, 1 second. Okay, so others are also, we have similar problems. We will go to taking up the word problem over here. The other problems are similar. Okay, I hope it's going to be very, very easy. Now we will start with solving the word problems. We have about 3 word problems, and there are other word problems also, which I'll be considering. Here the question says that Ravi obtained 70 and 75 marks in the first 2 unit tests. The minimum marks he should get in the third test to have an average of at least 60 marks. Okay, I think I have told you this, but I will repeat this again. At least and at most. So what does at least mean? I think I've given you an example, right? Say your parents tell you at least you get 90% and you get 95%. They'll be very happy. What does this mean? It means that you should be getting 90 or above. Yeah. So whenever we have at least, it is always going to be greater than or equal to that particular number. When you have at most, it is going to be, for example, they give you 1,000 rupees to spend, but you spend only 200. In that case, they'll be very happy, right? Because they will tell you at most you spend 1,000, right? So here it is going to be less than or equal to something. So whenever you are solving the word problem and you see at least, straight away plug in greater than or equal to symbol. Whenever you have at most, you can plug in less than or equal to symbol. This is one thing that you have to know. Now let me come back to the question. Ravi has obtained 70 and 75 marks in the first 2 unit tests. Find the minimum marks that he should get in the third test to have an average of at least, this is the keyword, right? At least 60 marks. So I know what is an average, right? So what is an average? How do we calculate the average? Average or mean, both are one and the same. It is sum of all the observation divided by total number of observation. For example, a1 plus a2 plus a3 plus an divided by n. Right? This is how I calculate my average. Now I will start by writing down, let Ravi get x marks in third test. If this is the case, I can start by writing down the equation. 70 plus 75 plus x divided by 3. This is going to be his average. At least means it is greater than or equal to 60. 60 can be written down as 60 over 1. Now you just cross multiply and solve. You should be getting your answer. So when I cross multiply, I should be getting my answer as 70 plus 75. 70 plus 75 is going to be 145, right? 145 plus x is going to be greater than or equal to 180. You get 145 to the other side, and automatically you will be having the value of x, which is going to be 30. So I can tell that Ravi must obtain 35 marks at least in order to get 60 as his average. Right? Any number greater than 35, that would increase his average. So in order to get minimum 60, he has to get a minimum of 35 on his third test. Okay, easy. Let me go to the next question. This is also a similar question. The only difference is instead of three, we have five observations. To receive grade A in a course, one must obtain an average of 90 marks or more in five examination. Here, at least is not given, right? 90 marks or more. What does this mean? Again, automatically, it is going to mean that you have to be taking or you have to be considering greater than or equal to symbol. Each of 100 marks, if Sunita's marks in the first examinations are 87, 92, 94, and 95, find the minimum marks that Sunita has to obtain in fifth examination to get grade A in the course. Again, you can start by writing let Sunita obtain X, or any variable can be taken, X marks in fifth exam. What does this mean? This means that 87 plus 92 plus 94 plus 95 plus x divided by 5 is going to be greater than or equal to 90. 90 can be written down as 90 over 1, and now you can cross multiply. Before I cross multiply, I can just add all of them. Yeah, so it is going to be 7, 7 plus 2, 9, 9 plus 4, 9. It's going to be carry 1, 8, carry 1. It's going to be 1, 8, 8, 9, 18, 18, 27, 8, 30. 30 plus 6 is going to be 36, right? So I should be getting 368 plus x, which is going to be greater than or equal to 9 multiplied by 5. 9 multiplied by 5 is going to be 450. Right? Now you transfer this to the other side, you'll be getting the value of x. X is going to be greater than 450 minus 368. Right? So what do you think the value of x is going to be? Here it is going to be 0, 8, so it is going to be 2, 45, 45 and 35. 45 and 35 is going to be 8. 45 and 37, it's going to be 8. So 82 is going to be your right answer. So minimum, Sunita has to get 82 marks in order to get an average of 90 marks or above. Okay, clear? Let me take up one more question, and this is based on consecutive numbers. Right? Find all the pairs of consecutive odd positive integers, both of which are smaller than 10, such that their sum is more than 11. This is the question. Now let me start by assigning the variables, right? Let x be the first consecutive number. If x is the first consecutive number, the next is going to be x plus 2, right? Because we are considering only odd. So it is going to be x, x plus 2, and so on. These are the consecutive numbers. Now, what does it say? We have to find out a pair of consecutive numbers such that both of which are smaller than 10. Here the number is very small, but please observe, because for the bigger numbers it is going to be a little bit, I mean, it's going to be the same thing, right? But the working method is going to be changing. Okay, now if I take up, right, x and x plus 2, both are the numbers, both of which are smaller than 10, right? Both should be smaller than 10, so x should be smaller than 10. Yeah, and x plus 2 also should be smaller than 10. So we have two inequalities over, isn't it? Yep. Yes or no?
Yes, sir.
Okay, okay. Now, what this is the another inequality that we have to consider. We also have to consider that the sum should be more than 11. Sum should be more than 11. So whenever I take up the sum, which is greater than 11. What does this mean? This means that x plus 2, right? This should be greater than 11. Now there are two inequalities over here. Which one should you consider? The first one or the second one? So from here, I get to know that x should be less than 10. X plus 2 also should be less than 10. So can I take up the second one over here? I'll explain the logic why. I'll explain the logic why. Okay. So if I know that x plus 2 is less than 10, automatically x will be less than or should be less than 10, isn't it? Yeah. For example, if 9 is less than 10, yeah, and this is x plus 2, if x plus 2 is equal to 9, right, in that case I can tell, of course, x is going to be 7 and 7 is going to be less than 10 as well, right? So we have two of them. You consider the second one over here, right? If it was x minus 2, in that case you should have considered which one? If it was like this,
X less than
x
10.
x you should consider, right? If x is going to be less, then x minus 2, of course it is going to be lesser as well. Perfect. Now, from this particular inequality, what is the value of x I get? I get that the value of x is going to be less than 8, right? So this is one of the boundary. What is the other boundary that I can take up? I can take it up from here, right? So when I add both of them, I'll be getting 2x. 2x plus 2 is going to be greater than 11. You can transfer this to the other side. So 2x is going to be greater than 9 now. Now x is going to be greater than 9 over. Since we are taking odd numbers, I can just take up 9 over here. Yes, yes, of course it's going to be 9 over 2, but I can consider this as 9 because we are considering only the odd numbers.
Yeah, sir.
Now, what are the possible values that you can take up? How many values are going to be there?
Sir, there aren't
Two
any
values.
such values, right?
Huh?
There aren't any such values, right?
There aren't any. One second. Have I done any mistake in that case? It should be, right? Mm, x plus 2, x plus 2. Okay, one second. One second. This is, got it. So this symbol is, it is greater than, isn't it? The sum should be greater than. Is that what I've taken correctly? Yes. Yes. I've taken correctly. Now,
Sir, 9 by 2 will become x greater than 4.5.
yes, that's what. So over here, 9 over 2, I can take this as 9. Yeah, 4.5, something like that.
Yeah.
Yes. So x should be greater than 4.5. So what does, I will just take the double inequality now, right? Why? Here you also we have x, here also we have x. So I can start by writing x, right? And x is less than 8 and x is greater than 9 over 2. I can write 9 over 2 as 4.5. So this is how I'll be getting my inequality as. So x should be in between 4.5 and 8. So what is the first odd number that you can think of? It is 5. The next consecutive odd number is going to be 7. So 5 and 7 is one of the solution set. Next number is going to be 7. If I take 7, 7 and 9 can I take up? Yes, 7 and 9 are possible here. 9 is going to be greater than 8, but not a problem, right? Because we are considering x comma x plus 2. We are just concerned with x. So these two are going to be the solution set. So these two are a pair of consecutive integers such that both of them are going to be less than 10, but their sum is more than 11. Is that clear? I have a couple more problems. We'll be solving that one as well. Okay. So coming to the next question. Fine. This is the same question. Okay. This is going to be 24th question. Find all the pair of consecutive even positive integers, both of which are larger than 5 and their sum is less than 23. So I will start by considering x and x plus 2 as the consecutive numbers. What is given over here? Both of which are larger than 5. So x is going to be larger than 5. X plus 2 is going to be larger than 5 as well. Here, which inequality should I consider? I should consider the first one, this one, right? If x is greater than 5, of course, x plus 2 has to be greater than 5, right? It's evident. So I can take up the first inequality over here. Next, what does it say? Both of which are larger than and such that the sum is less than 23, as in x plus 2 should be less than 23, which means that 2x is going to be less than 21. Divide both sides by 2 and you will be getting the value of x as, say, 10.5. Now I can combine these two inequalities to write down a double inequality. X is over here, so write down x. X is common, right? So it is going to be in the middle. And anything that is going to be greater is going to be on the right hand side, 10.5. And anything is going to be lesser, that's going to be on the left hand side. So this is the solution that I'll be getting. Now, which is a even number which is greater than 5? It is going to be 6, 7, and 10, isn't it? Yes. So if I take 6 as my number, the consecutive number is going to be 8. So this is one of the solution set. If I start by taking x as 8, x and x plus 2, it is going to be 8 comma 10. This is one more solution set. I can take up 10 and 12 as well. If I take up the value of x as 10, the value of x plus 2 is going to be equal to 12. So there are three set of numbers or three pairs of consecutive numbers such that both of them are going to be greater than 5, but the sum is going to be less than 20, right? So 6 comma 8, 8 comma 10 and 10 comma 12, these are going to be your options. Let me take up few more questions. I have two more questions. Okay, so what is this? I will this I will erase. Just a second. All right. This is the 24th one. Find all the pair of okay, this is done, right? This one. So this is based on triangles. The longest side of a triangle is 3 times the shortest side, and the third side is 2 centimeters shorter than the longest side. If the perimeter of the triangle is at least 61 centimeters, find the minimum length of the shortest side. So let me start by drawing a triangle this way, right? And let me consider this to be the shorter side, this to be the longer side, and this is going to be the third side, right, which is right in the middle. Now what is the inequality? It is given that the perimeter should be at least 61. This is what is mentioned, right? Now I will start by taking up the inequalities over here, and for that I have to assign something, right? I will start by writing, let the shortest side, let the shortest side be x meters centimeters, right? If this is the case, the third side is 2 centimeters shorter than the longest side. So how much is going to be the longest side? What do you think? So the longest side of the triangle is 3 times the shortest side, right? So I can start by writing down the longest side. In that case is going to be 3 times x, which is going to be 3x centimeters. And how about the third side? Third side as in going to be the side over here, right? It is in between shorter side and the longest side. Let the, where's that? Let the third side be, it is given as the third side is 2 centimeters shorter than the longest side. Which is the longest side over here? It is going to be 3x, isn't it? 2 centimeters shorter as in 3x minus 2 centimeters. So these are going to be the lengths that I'll be having. So what is going to be the shortest side? It is going to be x. The longest side is going to be 3x, and this is going to be 3x minus 2. Now the perimeter is nothing but the length of the boundary of a figure, isn't it? I just have to add up all of them. X plus 3x plus 3x minus 2 should be greater than or equal to 61. Transfer 2 to the other side, so it becomes 63. Add up all of them, it is going to be 7x. 7x is going to be greater than or equal to 63. You start dividing both sides by 7 and you have the value of x, which is 9. So minimum length of the shortest side should be 9 centimeters, and this is going to be your final answer. Is it clear how we have taken this? So these are the types of problem that we have discussed today. Okay, this is relatively a very short chapter, and in the next class, that is tomorrow when I come there, right, I'll be taking up a few more problems and let's discuss few problems from miscellaneous exercises as well. We have how to draw the graph and those kind of questions, right? What is a feasible region, what is a non-feasible region? So there are questions based on that, so I'll be continuing with that in the next class. Okay, so I'll be ending my class over here. I will meet you tomorrow at the same tomorrow we have at Wednesday, right? Wednesday it's going to be at 7:40. Okay.
Okay, sir.
So I think you know the timetable. Rather, I will just update it by evening. I will update it, but I'm just letting you know that it's going to be around 7:40, 7:30 to 7:40 because I have one more class at 12th. I have at tomorrow 6:30. Yeah. Yes, tomorrow is when is yes. So tomorrow I'll be taking for 12th from 6:30 to 7:30, and then I will start with 11th after that. Okay, so thank you for joining Aditya, Gautam, Namish, and Ritvik. I'll be meeting you tomorrow. Have a great day and wonderful week.
Thank you, sir.
Bye bye. And I will try to share the video as well. Okay, you can just have
Okay.
a look or not a problem. If you have understood, it's not going to be a problem at all. Bye bye.
Thank you, sir. Bye,
Good
sir.
night.